Hello students, welcome to this video. In this video, we will solve question number 341 to 350 of permutations and combinations. The link to download the PDF will be in description, as well as at the end I will show you how you can download from the website and maintain dates so that you can check for updates. So without further ado, let's get started. Question 341 says that there are 12 points in a plane, 5 of which are concyclic, and out of remaining 7 points, no 3 are collinear and none cyclic, with 5 previous points. Find the number of circles passing through at least 3 points out of 12 given points. So let A be uh, consisting of 5 cyclic points. C is missing here, and B the set consisting of 7 points. Case 1, circle passes through 3 points of B. Number of circles is 7C3. Case 2, circle passes through 2 points of B and 1 point of A. Number of circles is 7C2, 5C1. Case 3 is circle passes through 1 point of B and 2 points of A. Number of circles is 7C1, 5C2. Fourth case is circle passes through no points of B. Number of circles in this case is 1. Thus total number of circles is 211. Question 342 says that in a plane there are 37 straight lines, of which 13 pass through the point A and 11 pass through the point B. Besides, no 3 lines pass through one point, no line passes through both points A and B, and no 2 are parallel. Find the number of points of intersection of the straight lines. From 37 straight lines, we have a total number of intersections as 37C2. However, for 30 lines, we get 1 point A of 13C2. And similarly, for B, we get 1 point instead of 11C2. So total number of points of intersection is 37C2 minus 13C2 minus 11C2 plus 2, that is 535. Question 343 says that there are 2 lines L1 and L2 and there are M and N points on these 2 lines. How many lines can be constructed using these points? If we pick 2 points from M points, then third can be picked in N ways, giving us MC2 multiplied by N tangles. Okay, we have to find number of tangles. Okay, there is some mistake. This shouldn't be lines, they should be tangles. Alright. So if we pick 2 points from N, then third can be picked in M ways, giving us MC2 multiplied by M tangles. So the total number of tangles is N into MC2 plus M into MC2, that is equal to Mn into N plus N minus 2 over 2. Question 344 says that let Pi, where I is 1 through 21, be the vertices of a 21-sided regular polygon inscribed in a circle with center O. Tangles, it should be tangles, are formed by joining the vertices of the 21 sides polygon. How many of them are acute angle triangles? How many of them are right angle triangles? How many of them are obtuse angle triangles? How many of them are equilateral triangles? And how many of them are isosceles triangles? So the solution is, since this is a regular polygon with odd number of vertices, no 2 of the vertices are placed, it should be placed diagonally opposite, so there are no right angle triangles. Let A be the number of acute angle triangles and O be the number of obtuse angle triangles. To form a triangle, we need to choose 3 out of 21, which can be done in 21C 3 ways, that is 30 ways. Since the triangles are either acute or obtuse, we have A plus O is equal to 1330. Draw a diameter through points P minus 1. Now we consider points only on one side of diameter, including P1. So we need to select 2 out of 10. All these will be obtuse angle triangles. Number of such triangles on both sides is 21 multiplied by 10C2, that is 945. Thus number of acute angle triangles is A, that is 385. So this is the diagram. A triangle PI, PJ, PK is equilateral if these points are equispaced. Out of 21 points, we have 7 such triplets, thus we have 7 equilateral triangles. Consider the diameter P1OB. So the question is P1O and this should be D, where D is the point where P1O meets the polygon. If we have an isosceles triangle as P1 as its if we have an isosceles triangle at P1 as its vertex, then P1B is the altitude and the base is bisected by P1B. This means that other two vertices are equally spaced. It should be spaced from B. Clearly, there are 10 such pair of vertices giving us 10 isosceles triangle for each vertex. My spelling is wrong, it should be vertex. But one of these is equilateral, so we have 9 such triangles. For 21 points, we will have 189 such isosceles triangles. Since we can consider equilateral triangles as isosceles triangles, total number of isosceles triangles is 189 plus 7, that is 196. Question 345 says that let U be a set containing n elements. A subset S of set U is chosen at random. The set U is reconstructed by replacing the elements of S, and another set T is chosen at random. Find the number of ways of choosing S and T such that S union T contains exactly R elements. So S union T has R elements. That means out of n elements, R elements are present in either of S or and T or in both. Thus, each element has 3 choices. Number of ways of selecting elements for S and T are 3 to the power R. Remaining n minus R elements have only one choice, and that is to be not in either of S and T. Total number of ways of selecting n minus R elements is 1 to the power n minus R, that is 1. Now, R elements can be selected from n elements is NCR. So total number of ways is NCR multiplied by 3 to the power R. Question 346 says that let U be a set containing n elements. A subset S of set U is chosen at random. The set U is then reconstructed by replacing the elements of S, and another set T is chosen at random. Find the number of ways of selecting S and T such that S is equal to T bar. That is, I think it is a complementary set notation. So we have S is equal to T bar. This means an element is either present in P or Q. Thus, for each element we have two choices. Hence, total number of ways to select is Q to the power n. Question 347 says that what is the total number of subsets of a set containing n elements? So this we will study in 347, containing n elements. All right. So we let U is equal to A1 through An be a set of n elements. Let F be the set of all subsets, and B be the set of all binary sequences of n. So we let A is in S. We let F as a function such that its domain is S and range is B. Be a function that associates a binary sequence with B as follows. AI is in B if ith term of the sequence is 1. For example, subset A2, A4 through An minus 1 corresponds to binary sequence 0, 1, 0, 1, 0, and 1, 0. Observe that for every subset there is a binary sequence of n terms, and for every binary sequence of n terms as stated above, there is a subset B of U. Therefore, F is the bijection between S and B, hence number of subsets is equal to number of binary sequences, that is 2 to the power n. This you can prove by binomial theorem as well. We will see when we study binomial theorem, what happens is the expansion of 1 plus x to the power n is nc0 plus nc1x plus nc2x square plus nc3x cube and ncn x to the power n. Now, this represents selection of 0 out of n, selection of 1 out of n, selection of n r out of n. So where r varies from 0 to n. Now that is the total number of subsets. So if you put x is equal to 1, then it becomes 2 to the power n. Now 348 gives us a figure. Path from A to B consists of horizontal or vertical segments. No diagonal movement is allowed. We can only move from left to right or down to up. How many paths are there from A to B? How many paths go via C? How many paths go via C to D? So we assign H for horizontal movement and V for vertical movement of 1 unit. One such path would be H, 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 V, 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 H, H, V, H. Note that there are 7 horizontal and 6 vertical line segments of 1 unit each from A to B. Since for every path between A and B, there is a sequence of 7H and 6V, and for every sequence we have corresponding one path made up of horizontal and vertical lines. Therefore, there is a bijection between the set of all paths from A to B and the set of all sequences of 7H and 6V. The number of paths from A to B is equal to number of sequences. That is equal to number of ways to select 7 places to put H out of 13 different places. That is 13 is 7 or 13 factorial by 7 factorial into 6 factorial. Number of paths through C is equal to number of paths from A to C multiplied by number of paths from C to B. That is number of ways to select 4 places to put H out of 8 different places times number of ways to select 3 places to put 3 out of 5 different places. That is 8C4 multiplied by 5C3. Similarly, number of paths from D to B is 4 factorial upon 2 factorial multiplied by 2 factorial. So number of paths including CD is 8 factorial divided by 4 factorial into 4 factorial multiplied by 4 factorial by 2 factorial multiplied by 2 factorial. I think, no, it's not. Question 349 says that find the number of ways in which we can choose 3 squares on a chessboard such that one of the squares has its 2 sides common to other 2 squares. So we have the chessboard here, and these are different possible places where we have 2 sides common. For the 2 sides to be common, we have L-shaped possibilities. Consider 2 by 2 square shown. In this case, we take 1, 2, 4 or 2, 4, 3 or 4, 3, 1 or 3, 1, 2. Then we will have one square whose 2 sides are common with others. That is, if we have 4 such squares. Now, if we fit this square block among the 2 rows, we will have 7 such blocks and 7 along columns. Thus, total number of required squares would be 4 multiplied by 7 multiplied by 7. There is a missing 7 here, that is 1 under 6. Now, the other possibility is a contiguous block of 3 squares, either horizontally or vertically as shown. We will get one required square in the middle of the blocks. Along the rows and columns, we can fit 6 such blocks. The required number of squares is 2 multiplied by 6 multiplied by 8, that is 96. Thus, total number of required squares is 292. Question 350 says that a person predicts the outcome of 20 cricket matches of his home team. Each match can result either in a win, loss, or a tie for the home team. Find the total number of ways in which he can make predictions so that exactly 10 predictions are correct. So we will prove this by negation. Since we have to make 10 exact predictions, this implies that we have to make 10 wrong predictions. Number of ways to select 10 matches out of 20 is 20C10. Now we can make mistakes in 2 ways. Thus, total number of making mistakes is 2 to the power 10. Thus, total number of ways of making 10 exact correct predictions is 20C10 multiplied by 2 to the power 10. So with this, we come to the end of 35th set of videos. Okay, and I hope that you are enjoying this series of playlist and finding the videos useful for your exams and studies. So as you can see, questions have become involving now. We have finished 350 questions, and now there will be 175 more questions are there. So another 18 days and we will finish the combinatorics or different combination. To download the PDF, you come to my website astrobuck.org. Second link is this PDF which I am using, Algebra. The third one is trigonometry and fourth is coordinate geometry. You can download and read any of these books. So a fair piece of warning is that there are lots of typing mistakes in these books, which is kind of good in a sense that you just can't blindly trust it. When you look at the solution, you have to be careful that the solution is correct. Okay, if everything would have been perfect, you could copy the solution, but it won't work for this. Lots of solutions may have lots of typing mistakes. The other thing is that when we download, you rename the book to include the date, so that when you come back later and you see the date has changed, then you download it again. So with this, we can end this video here. Thank you for watching the video, and if you have to say anything, make use of comment box. The question answer forum website is coming up soon. I will deploy it within maybe 3-4 days or a week at most. And then instead of comment box, you can create login over there and you can discuss various things. So once again, thanks a lot for watching the video. Keep solving the problem, and I'll take my leave, and we will meet again tomorrow with a new video. Thank you and bye.